Okay, 20.5 formulas for electric fields, page 44. In the last session, 20.4, we know that what is the electric field and also electric field strengths. In this session, we will focus on the formula, on the calculation. The first of all will be the radial field. Radial field usually will be coming from a point charge. For you should remember this one. When we have a point charge, then the electric field will be like that. Point outward from the center. Then this one we will say that radial field. If the charge is a positive one, we will put the positive test charge on it. Then we can find that the force is the repulsive force pointing outward. In this case, this force we will call it positive. On the other way, if the charge is negative, we will have the attractive force. Then this one we will say that negative sign. And based on the Coulomb's formula, we have this, the product of charge, and also depends on the separation between them. We have the permittivity. Okay, we have this formula. This formula tells us that the force acting on the test charge, what is it? Depends on the Q, the field produced by capital letter Q, and also the Q as lowercase q, the test charge. Based on the definition of the electric field strength, should be the force per unit charge. This unit charge should be the value, the quantity of the test charge. Then in this case, it means that the E field, the electric field strength, should be depends on the position of the test charge and also the charge which produce this field. Okay, should be independent of the test charge, because the test charge we will think that will be 1 unit. Based on this equation, we can know that if you go to a certain position, then what is the field strength? You can calculate from this formula. Remember that this formula just only true for point charges only. It means that the radial field. Longer in distance, it means that the distance from the center of the charge. Farther away, then the force acting on the test charge will be smaller. It means that the field strength should be smaller. This one is the inverse square law. Now look at example 12. This one, electric field of a point charge. In this case, this one usually appear in the MC, tells you something using the grid 9. And look at this, we have the point charge x and y near to the charge Q. Find the magnitude of the electric field strength at point A and point B. Point A and point B. Once again, this one is a one charge, one single charge. The field set up by this will be a radial field. Okay, very simple one. And now look at this, point A, this one. What should we do? First of all, this one we want to find out the field strength. It means that you should put 1 unit of test charge on it. Okay, actually, the value of the test charge is negligible. When you want to find out the field strength should be depends on the charge Q and also the distance. This one, focus on this Q and the distance between them. For B, similarly, the distance between them. So what should you do? You should find out the distance first. This one should be in vertical way will be 2 grips. For the horizontal one, 1 grips. And then how about Y? Horizontal one, 2 grips. Vertical one, 1 grips. Then from this you can find that the length of RA and RY should be the same. Okay. Go back to the question. The question tells us that what is the field strength at A and at B, because the question gives us this value. Okay, if the distance is 1 unit, then should be 360. If this one is In horizontal way, 2 grips, and vertical one is 1 grip. You can use the Pythagorean theorem to find it out. Then this one should be 72. Okay, so based on it, then you can find that the electric field strength at A should be the same as Y. Okay, because they have the same distance from the charge Q. Okay, they will have the same electric field strength. Similarly, how about B? B should be depends on the distance. This one is 1 unit, 360. How about this? Of course, you can use the Pythagorean theorems to do it. This one is 3 unit, 1 unit. Afterwards, the length of the diagonal should be square root 10. Okay, and then by using this ratio, ER square, it means that this should be a constant, no change at all, because we'll use the same Q and also same environment. It means that same permittivity. Okay, so you can find that this one, and then using the relationship, you can find that the field strength should be 36. Okay, that's all for this example. Okay, how about next? Charged spheres. And formula of it should be this. Okay, you can think that all the charges on this surface should be concentrated at the center of it. It means that the center can represent the whole thing. Then, because of it, using the Coulomb's law, you can see that for a ball and for a point charge, they are the same. Then, how about the electric field strength? The same concept. It means that we can apply the same formula in it. R should be measured from the center of it. Outside of it, inside it, we have the other formula, but this one is out of series. Okay, part B. A resultant field of many point charges. It means that in the world we will have many different charges around it. Then what should you do? You should try to find out the vector sum of it. Look at this one. If I want to know that what is the field strength at that point, okay, you should try to find out the relationship between this test charge, if you place it on it, and also the charge around it. For example, in this case, we have Q1, Q2, Q3, and Q4. It means that we have 4 interactions, 4 different forces. We have these 3 different forces, and then add them together should be total net force. This total net force will be true for a point charge with lowercase q. But in order to find out the field strength, you should divide it by lowercase q. It means that per unit charge. Then you can find out this electric field strength. Okay. Mathematically, add them together like that. Okay, example 13. Okay, electric dipole. We want to find out the electric field strength at point A. Then what should you do? Try to find out the force acting on A due to positive charge Q and also the negative charge Q. If you focus on the force, positive will be positive force, positive and negative will be attractive force. But please focus on the distance between them. For the negative one will be greater in distance, the force will be smaller than the repulsive force. The resultant should be in this way, okay, towards the left hand side. And because of it, you can apply the formula 2 times. One for positive one, the other one will be the negative one. Point A and point B. Point A is more easier one. Try to do point A. It means that the part A first. Look at point A. If you put a test charge on it, it will have 2 electric field strength, or we have 2 electric force adding on it. Or towards the left hand side will be greater than the right hand side. Based on the equation, we can find that they are different in distance. One is 2, the other one is 2.001. Okay, you should add them together to get the resultant electric field strength. Will be EA. What is EA? Add them together, but pay attention on the sign. The final answer is this. Okay. In this case, you should focus on the direction. The direction will affect the value of it, because if they are different in direction, then one of it will be positive, the other one may be negative. Add them together, the value will be smaller than before. Okay, part B. Part B will be like that. Okay, you can see that they have the same distance from B to positive charge and from B to negative charge. They have the same distance. It means that they should have the same magnitude. But remember that their direction are not the same. Okay. You can use the formula. You can find that this value magnitude only. But in mechanics, you should know that if they are not the same direction, like that, okay, you can use the parallelogram method to find out the resultant. The resultant should be the diagonal of the parallelogram. But in this case, we will use the component to do it, because we know that the vertical component for E positive, this one, and the component of the E negative in vertical direction, they are the same in magnitude but opposite in direction. When we add them together, they will cancel it. Then it means that we just only focus on the horizontal direction to find out this component for E positive and E negative. For E positive, in this way, the horizontal one should be cosine function. For E negative, also cosine function. It means that add them together, and also we know that E positive and E negative should be same in magnitude. Okay, add them together should be 2 times. Finally, we can get this answer. Once again, in this topic, you should know that the method will be similar to the question in mechanics. What if question? What happens to the electric field strength at A and B if positive and negative charges are much closer to each other? It means that the distance between them is smaller and smaller. Then what happens? Okay, this one will be before, and then after, because they come close together, their difference will be smaller than before. When you add them together, the resultant E field will be less than before. How about this case? Okay, come closer will be like that. Then in graphical method, you can see that the resultant, it means that the length of the diagonal will be smaller than previous one. It means that should be smaller. Okay, next one. If we have more than 2 charges, maybe 4, then what should you do? The same method. Okay. In this part, we focus on the E field at the center. In this case, what should you do? You should focus on the force provided by the pairs. For example, positive should be repulsive force. Positive repulsive force. Positive will be repulsive force. positive, negative attractive force. Once again, because they have the same charges, the magnitude of them, and also the distance should be the same. It means that the magnitude of each force should be the same. This one and this one will cancel each other, and this direction will be double of it. Finally, the resultant will be this way. Okay, cancel out. The red arrow will be the resultant. The resultant in this case we will call it reinforced.